Hi guys, welcome back to Symbolic Logic part 16. So far, in symbolic logic, we have seen about what is meant by symbolic logic and what's the difference between classical logic and symbolic logic. As the first topic, we have studied about simple statements and compound statements. And in compound statements, we have studied about different types of compound statements. Let's recall what are the different types of compound statements. So, in symbolic logic, we have five types of compound statements: conjunction, disjunction, negation, implication, and equivalence. Conjunction in the sense we use and in it. In distinction, we use are, and in negation, which is the opposite, and implication states if then. In equivalence, we have studied about biconditional and tautologies. So, today in symbolic logic, we will be studying about some terminologies. So, the first term which we are going to see is truth value. As you know, truth value refers to the property of a statement or proposition that indicates whether it is true or false. In logic and mathematics, truth value is often represented by a binary system where a statement can be assigned either true or either false. So, what is mean by truth functional component? All the components which we saw earlier, I mean the conjunction, distinction, negation, implication, equivalence, comes under this category of truth functional component. So, the third one is truth functional compound statement. What is mean by that? A compound statement whose truth value is determined wholly by the truth value of its components is known as truth functional compound statement. Now let's see about truth functional connective. What is it? Any logical connective. Example, conjunction, distinction. In between these components of truth functionality compound statement is called truth functional connective. The connective between these components. So, many of the you aware of truth table and truth table method overall. But in symbolic logic, we use this truth table and truth table method to prove the validity and invalidity of an argument. When it comes to invalidity, we will be using a shorter truth table method to prove its invalidity. So, in common, a truth table is a table used in logic and mathematics to represent the truth values of a compound statements. So, at last we have punctuation, which includes parentheses, brackets, and braces. In symbolic logic, just as in ordinary language, punctuation becomes absolutely required if we have complicated statements. We want the complicated statements to be clear so that we can solve it. So, we use many different punctuation marks. Without this punctuation mark, the sentence, highly complicated sentence, would be ambiguous. So, punctuation is completely, absolutely necessary in symbolic logic. Now, let's see the importance of punctuation. So, let's take an example. If you look into this example, number one, the first statement says, the philosopher says the layman is a fool. And the second sentence says, the philosopher says the layman is a fool. And the third sentence says, the philosopher says layman is a fool. Each sentence is giving different meaning, right? With the use of punctuations, we can easily identify what the author is trying to tell. So, without punctuation, this sentence would be literally ambiguous. That's why we need punctuations in symbolic logic. So, we have studied about the terminologies in symbolic logic, which is required to study this symbolic logic in understanding way. In previous session, we have seen about different component statements, right? Different types of component statements, right? Which includes conjunction, disjunction, negation, implication, and equivalence. In this session, we will be seeing about the truth table for the five types of compound statements. So we will be having a variable p and q with constant values, true or false. And the first one we have is p dot q. Dot is the symbol which represent the conjunction and. So if conjunction, if both the values are true, then it is true. Other than that, everything will be false. And the next thing we have is either or. Or refers to distinction. In distinction, other than the truth values false, everything will be true. And the third one we have is implication, which is if then. In implication, other than t of values, every else will be true. And the fourth one, what we have is negation, which is the opposite. What we say, it is not the case that. We will be saying the opposite of the case. In negation, this true false is false true is true, and false false is true. So if you taking negation of p means if p value is true, then negation of p will be false. If p value is false, then the negation of p will be true. Same goes for q too. Negation of q means false will come. If q is false, the negation of q is will be true. So it will be the opposite. If negation p or negation q, it will be the opposite. So the last one we have is biconditional, which is equal to or tautologist we say. So in biconditional, if we have the same truth value, truth means it will be true. If we have different truth values means it will be false. So I need everyone to understand this truth table clearly, and you guys need to remember this so that we can able to solve the problems in the upcoming sessions in the east. So we will be using this truth table throughout the end, which is absolutely necessary in studying the symbolic logic. So this is for today. Thank you for listening.